Ja hoor.
Fuck, dit is echt...
More power.
Ja, als het goed is wel.
Daniel, could you briefly explain how you make sure the pod levitates inside the track?
Yeah, so one of the key defining aspects of a Hyperloop system is levitation. To achieve full levitation, we use a system we call HEMS, Hybrid Electromagnetic Suspension. This system uses a combination of permanent and electromagnets. Permanent magnets hold the bulk of the pod's weight, while the electromagnets make sure that we can steer our air gap precisely. For lateral levitation, we use a series of electromagnets along the side of the pod. These help us to keep the pod centered at all times. And by combining these two principles, we can actually achieve full levitation while using less energy than a vacuum cleaner.
And can you explain the basic principles behind the propulsion system?
Yeah, so since we don't have any physical contact with the surrounding infrastructure, we rely on a magnetic field to pull ourselves forward in the infrastructure. So this is done by placing coils around a steel laminated U-core, guide the magnetic field that is produced, and then we can pull ourselves forward onto the steel teeth that are present in the infrastructure.
I thought that a Hyperloop levitates, right? So why does it also need wheels?
So there are multiple reasons why a Hyperloop system also has wheels or safety sleds. For example, if you're mid-run and you have a power outage, then you still want to be able to safely land on your safety wheels or sleds. When starting to tune our levitation system, we expect it to start shaking around a bit violently. So in order to protect the pod, but also the track, we have safety suspension in order to prevent any damage. We started with the bottom safety wheels, which we needed for the drop test, which you might have seen in the previous episode. And after that was completed, we installed the rest of the safety suspension system. So it started with our magnets engineers spending a lot of hours, sometimes even deep into the night, performing a lot of simulations to get the best coil configuration and optimal geometry of the motor. After these simulations, we ordered all the components and then we started with the assembly. This started with placing the coils into their housings and then pouring epoxy over them. Then you place them onto the laminated steel U-core and making sure that this configuration is always right. And also what makes our motor special is that we have developed a completely new kind of configuration that hasn't been tested before. One of the challenges that arise with this is that you always need to keep the pod perfectly centered. As you may know, magnets get stronger the closer they are to something magnetic. So what this means for us is that when the pod is not off-center, the forces that are actually pulling you off-center get even stronger. And one of the solutions for this is our innovative control system, equalizing thrust while maximizing lift controller. The assembly went quite well, and then we started testing downstairs in our workspace where we have built a linear test setup. And then at first it didn't really want to work. The test setup wasn't stiff enough and we had a lot of communication problems with the ground station. And at a certain point I was starting to get a bit worried. But after fixing the setup, making it more stiff, fixing the communication problems, it almost went instantly at the first try. And yeah, that was quite the relief.
Oké. Je hebt hem niet slecht verstaan, hè? Ja hoor.
Ja hoor.
Ja, nee, Daniel.
Dat weet ik nu al zo.
Prince, are you happy?
Ik ben best wel blij.
Oh, schatje. Goed zo, gefeliciteerd.
Het ging echt heel snel heel goed. Fuck, dit is echt more power.
It was crazy. Working on that motor for so long and finally seeing it in action, that was one of the major highlights of this year.
And Daniel, what is the final step?
So now we have verified that all the hardware can work independently. And now it's time to integrate everything, put everything on the chassis. And then we're going to move to the tent where we're going to start testing. And then we're going to really create a fully functional Hyperloop system.